Amity International Business School, Amity University, to welcome you all at the inaugural and followed by the paper presentation of Springer and IEEE. It is the fourth esteemed international conference by the name of Intelligent Engineering and Management, ICIEM 2023, which is being held at Berwick University in London. We feel honored to have our presenters from different countries. The presenters are from Hungary, from Japan, from Saudi Arabia, from India. And before we go ahead with the IEEE presentation, wherein we have enormous response, I would like to call David, who is from Hungary, and he belongs to the Springer presentation. The title of his presentation is Low-Level Real-Time Graphics and GPU Programming in C#. David, over to you for your presentation, please.
So much. Can I start? Right, so welcome everyone. Thank you for having me. My name is David Szabó. I am a doctoral student from Budapest, from Hungary, from Eötvös University, from the Faculty of Informatics. So my topic is going to be about programming and a little bit of computer science. I hope I will be able to give you some interesting experiences and knowledge in this area. The name of my topic is low-level real-time graphics and GPU programming in C#. And if you understand these keywords, then you may realize that this topic is a combination of two areas in computer science. One of these areas is the graphics and GPU programming, when you are creating rendering applications that can present something on the screen, present any kind of graphics on the screen. And the other area is the programming language, is the C# programming language, which is a high-level programming language which can be used to develop multi-platform applications. Usually these two areas, the graphics and the C# programming, are not tied together. And I'm going to talk briefly about why and what is our proposed solution to this problem. So let me give you a little overview about this area. First, the graphics programming. Yes?
I'm sorry, I'm wondering, it is stuck. So maybe this, we need to reshare the slide. Can we start once again?
Sure.
Is it open, right? Yes.
Thank you. So beginning with what is GPU programming, what is graphics programming? In order to do graphics programming, you need to use one of the graphics APIs. These are one of the most named one, the Vulkan, OpenGL, and DirectX. These are programming libraries which you can use to access the GPU, the graphic processing unit in your computer. And these are low-level libraries which you can use to issue drawing commands, to set the state changes on this graphics device, and so on. This is what you use for rendering, for presenting anything on the screen. If you use something higher level application, then it is probably built upon these graphics APIs that you see here. The other area is the C# programming language. Just a moment. All right, the C# programming language, which you can see in the bottom in this example. Well, the C# is a multi-platform application development language. In C# you can develop for Windows, you can develop for Linux, Mac, Android, iOS, and all of the operating systems, even for mobile, even for web pages. And C# allows you to implement your application only once in a single shared code base, and allows you to recompile this single shared code base to each of these operating systems and platforms. You don't have to remake your own real application all the time for every operating system. C# lets you implement your application in a standard library and share the same source code between all of these operating systems. And as you can see in this spider web, the problem is that the graphics APIs, the GPU programming, doesn't support this on its own, because each of the graphics libraries have different platform support. For example, DirectX only support Windows. The left one, Vulkan, the red, supports multiple platforms, but only the newer devices, the higher end devices and more performant devices. OpenGL supports multiple platforms as well, but it's an old API, isn't really future-proof to use anymore. And I still haven't talked about Apple devices, still haven't talked about the web. All of these platforms have different approaches how you can program some graphics on them. And this is a problem. If you want to develop graphics in C#, you cannot just pick a single one of these APIs. You have to use multiple of them to reach as many platforms as possible. So you may ask, why don't you use a high-level engine like Unity or Stride or any other of these graphics engines or video game engines or something like this? Well, my goal is not to use a ready solution, an already ready-to-use rendering solution where you can only scratch the surface of a rendering pipeline. My goal is to implement a rendering engine, to implement my own rendering solutions. I want to handle GPU resources manually. I want to render I want to render using custom rendering pipelines and so on. I want to do everything by hand, but is given by us by Unity and these high-level languages. So our proposed solution to this problem is a prototype library that we are developing, which supports the implementation of real-time graphics applications using C#. It is going to be a low-level library. This prototype is a low-level programming library. And the use of it is similar to the use of the graphics APIs, the graphics libraries themselves, but it's abstracting their differences. It is not said when you're programming your rendering engine, when you're programming your rendering algorithm, it is not tied to graphics API. You can decide on the executing graphics API later. It is made for C#, therefore it fits well into the C# ecosystem. You can inject your rendered images into C# user interfaces and the C# already made applications in C#. It is multi-platform. It supports compiling a single code base for multiple platforms. You can implement your rendering algorithm only once and can be distributed for all operating systems. Currently, I'm only supporting, or we are only supporting with this library, Vulkan and OpenGL, because these are the two ends of the spectrum. Vulkan is the lowest level, OpenGL is the highest level. So if we can support these two, then the two ends of this spectrum, we are confident that all of the other APIs will be supported as well. The images that we can see here are some proof of concept applications developed by this prototype library. The upper one is a ray tracing application where we trace the light rays from light sources like the sun, and we trace these light rays, which objects, in this case spheres, are hit by these light rays, and we trace the reflected rays into our eye, into a virtual camera in our virtual world. This way we can accurately represent how the light behaves in our virtual world. And the lower one is the Sponza atrium. Sponza is well, an atrium in Croatia, and this model set is widely used by graphics developers to present some researches and advances in computer science. Here we are presenting that this using this library, we are capable to render more complex words, virtual words as well. It's more than 500 objects in the lower image. So if you're wondering how you can use this prototype library, this is a sample source code for the Hello World application, the Hello Triangle application. This is the simplest rendering application you can get. So this is the introduction or the tutorial example, we should rather say, where you just render two triangles. Those are two triangles. They just blend the colors. And if you programmed in anything like OpenGL and Vulkan, you may realize that, yeah, this source code is familiar. First, you are trying to begin a frame, then you're beginning a new render pass into this screen, into this frame buffer with that color. You can see here that orange-ish background color. Then you are issuing a drawing command to render these four vertices, these 4 points in the corners, which will formulate these two triangles. Then you just lastly present the frame because you issued everything to finish. This is just a simple example, but the same kind of structure, the code structure is used for these more complex applications as well. Obviously, you need to add more calculations in these for these applications. But when you are implementing a rendering engine, when you are working in such a low level, then you need so many lines of code to render such a simple thing. This is the structure of a prototype library. The right blue box is the user of a library, so the programmer who is using a library. And as you can see, we have an abstraction layer, that base library. This is what the user of a library mostly works with. And using this library, you can access these graphics features like render path and pipeline and all of these graphics features. And you can implement your own rendering solution with these. And when you're implementing your application at this level, it is not clear which API will execute these rendering codes. The decision about the used API is deferred until you launch an application. When you launch the application, you can select OpenGL, you can select Vulkan, and you can select all of the other graphics APIs in the future to execute the rendering code based on what device you have, what operating system you are executing on. So just the closing thoughts about this presentation. We are developing a prototype library for C#, enabling low-level real-time graphics programming, real-time graphics application development, and custom rendering solution development. And we are aiming for multi-platform support in C#. Currently, we are supporting Vulkan and OpenGL for this endeavor. And we support implementing the rendering code, the rendering solution in a single code base just one time and recompiling that single code base for multiple platforms. And this will fit well into, this library could fit well into C# ecosystem because you can reuse this library in already existing applications. You can render into existing applications user interface with this library. That was all I had for today. Thank you very much for your attention. If you have any questions, I'm ready for them.
That was sweet.
Thank you so much.
Does anybody has a question, please? In the IEEE team is open to ask if any question. Any question? All right. Thank you, David.
Thank you so much for having me. Thank you.
Now we keep our best foot forward and start with IEEE, WIE, UK, and Ireland track of the IEEE conference today. And before I go ahead, I may request the welcome note by Dr. Nagma Sayed. And I would like to introduce her to my August gathering out here. Dr. Nagma Sayed has been teaching and researching in the electrical and electronic engineering field since 2007. Dr. Sayed is the head of Industrial Internet of Things Research Group. She completed her PhD research titled Intelligent Man Optimization System at Brunel University, UK in 2011. She has written extensively on energy efficient intelligent systems in smart cities using artificial intelligence and optimization approaches. Dr. Sayed has published a respectable number of high-quality publications in well-known international journals related to various disciplines, including telecommunication, modeling and simulation, industry application, information, and smart power. Dr. Sayed is a senior fellow in HEA, member in IET, senior member in IEEE, IEEE officer, IEEE Women in Engineering, UK and Ireland Steering Committee member, and IEEE UKI WIE Early Professional Lead. She also mentors the early career engineering students. And my dear August gathering, I request you all to please welcome them with a huge round of applause.
Thank you very much, Doctor. And just do share the presentation and some. All yours. Thank you. Thank you very much, Doctor. So, dear participants, it's with a great pleasure that I welcome you to the session of the role of digital technology in supporting the United Nations Sustainable Development Goals. This session aims to explore the significant impact that digital technology can have in achieving the SDG. As we all know, the SDGs are a set of 17 goals adopted by the United Nations to achieve the sustainable future for all. Digital technology can significantly support these goals by providing innovative solutions, enhancing monitoring and evaluating, promoting inclusive participation, and increasing access to information. The role of digital technology is crucial in supporting the United Nations Sustainable Development Goals for several reasons. The first reason is increased access to information. Digital technology has made accessing information and knowledge about the SDGs easier. The internet provides a platform for the dissemination of information, enabling people to learn about the SDGs and take action toward achieving them. The second one is improving communication. Digital technology has made it easier for people to communicate with each other, regardless of their location. This has facilitated collaboration among individuals and organizations, making it easier to work toward that goal. The third point is enhancing monitoring and evaluation. Digital technology has provided tools for better monitoring and evaluation of progress toward achieving the SDGs. For instance, data analytics tools can be used to track progress and identify areas that require more attention and investment. The fourth point is innovative solutions. So digital technology has enabled the development of innovative solutions to the challenges faced in the world today. For instance, technologies like blockchain can be used to improve supply chain management, while artificial intelligence can be used to identify patterns and make predictions. The last point is inclusive participation. So digital technology promising us to promote inclusion and participation in development process, ensuring that everyone's voice are heard. For instance, social media platform can be used to engage people in discussion and just giving their appointment ahead. So in this session, we will have the opportunity to learn from experts in the field experts in the field who share their insight on how digital technology can be used to support the SDGs. We will explore case studies, best practice, and emerging trends that can help us to achieve the SDGs faster and more efficient. I hope this session will provide a valuable platform for exchanging ideas and experience, and it will inspire us all to take action toward achieving sustainable future for ourselves and generation to come. Once again, welcome to the session, and I wish you all a fruitful and engaging discussion. Thank you. Shall I introduce Professor Elsa?
That would be great.
Yeah. So I would like to introduce Professor Elsa from UCL. So Professor Elsa is a professor of complexity science at the Center for Advanced Spatial Analysis, University College London, a fellow of the Turing Institution and an honor professor at Hong Kong University. She holds a master and a PhD in theoretical physics from the University of Cambridge. Before joining UCL, she investigated processes of self-organization in ant colonies and social systems at Complexity and Networks Group at Imperial College. For the past 10 years, her research has been focused on cities and urban systems in general, such as emergence of hierarchies, the characteristics of resilience, the emergence of innovation, and the modeling of a coupled system. So welcome, Professor.
Right. So before I start, I need to switch computers. Which means that you need to bear with me 1 second.
That recording is there in that system. You want your system to be connected?
Yes, but it's just that either maybe why don't we exchange computers?
If you need this.
Okay, can you hear me better? Okay, perfect. And maybe we switch off this video. And I switch on this one here. All right, so here I am. Yeah. So I think my screen at the moment. Sorry. All right, we manage. Hello, everyone. So I hope that today I'm going to illustrate a bit why do we need complexity science in order to try to approach any of the problems that we are thinking about when we think about sustainable development goals. Is any of you familiar with complexity science? No, you've never heard about it? Well, of course, Mona. Right, so let us start then from the beginning. So when you think about AI and you think about patterns and you think about all the kind of computational science that you can put into your models in order to extract these type of things, actually what you have is something that emerges from the local interactions, okay? So when you think about agents, if you do ABM, if you do any type of things, what you have are individuals that when they come together, they do something more than that. And the one at the back, do you want to tell us a bit more about this? No? Okay. Right. So maybe what you will have are communities coming together in order to create something. So you have here the individuals, and these individuals, you can see that maybe in this case, you have individuals that are more connected to many different communities. We don't know how these are connected or not, but we know that these individuals are embedded in space. How they're going to be able to communicate between each other, the different communities emerging in space. Why are communities emerging in space? Maybe because they share culture, maybe because they share something that is beyond, you know, they study together, or there is something beyond what the individual has, that once the collective comes together, creates something, an emergent pattern that doesn't belong to the individual. Okay, so how are these individuals going to interact? How are the communities going to be able to take on a new technology? Am I going to get vaccinated? Is my neighbor going to get vaccinated? So how is this information going to spread into the system? Okay, if I want to create a new startup, how is it that I'm going to distribute information about my startup so that it connects everyone? Right, so you start to see how everything, even though might be on social media and all that, our embeddedness in the space cannot be detracted from that, okay? But this embedded in the space very much relates how the interactions are going to be modulated, relates to the infrastructure that you have in there, right? So how I'm going to be able to connect to the other community? Is there a railway blocking my way? Can I just go in there and communicate with the others? So you see that my interactions, the amount of interactions that are going to take place in the space are modulated by these networks that are out there, right? These networks can be our road network, they can be our public transport system, the underground, and so forth. But these two also interact with each other. And how they are interacting with each other very much creates this multiplex, these complex systems, okay? How you're going to change the availability of people to interact from this community to this other one very much relates, can I create maybe a fast line? Is it about communities? Is it about accessing a work? But then if you take this system separately, so we know that already in order to be able to interact with our communities, in our city, we have our transport system, our buses, our cars, whatever we have in our street network. We also have the underground that some people might have experienced today, a bit of difficulty trying to navigate this new system. It connects different points in a different way, right? So we need to think in a different topological sense. But these two are interacting. How you're going to make measurements in one system is different if you consider that they are coupled than if you consider them separate. Okay, if, for example, you would like to measure congestion, if you measure congestion in one system and you measure congestion in the other one, you cannot just put them together. You know, they're interacting. So the outcome of your system, how you're going to analyze your system, depends on putting these two things together. So you have coupled systems, we have different observations, different measurements than the sum of the individual systems. Okay, one person is not culture. Many people coming together creates culture, okay? One cell is not life. All the cells coming together creates life. That's a complex system. When you have many interacting components coming together to do something more than the sum of the individual parts, okay? So you start to see how, in addition to all of this, you have a relationship between all these systems, okay? So we started talking about the individuals here. We started talking about the behavior of the individuals in the community coming together, creating a new kind of emergent pattern, which is a collective behavior, right? That we said is culture, but maybe it's something else, okay? And you can think about many types of organizations in your society. How you're going to allow these individuals to interact, we already said, transportation systems. So how these are operating in your city will allow mixing, or we're enable segregation of the different communities, okay? So you can see how you can start changing what is happening here at the collective very much depends on these other things. And many people start to think, okay, but if I'm trying to think about my city, I'm going to think about transportation, not only with respect to the individuals and how they will be able to interact, but also because I want to link households to employment. I want to create opportunities for people, right? So I'm not going to put transport in a way only to have the richest achieving, going to work quicker, right? What do I want? I want equality. I want to be able to give new opportunities to the people. I want to be able to mix individuals so that you can see that by going together to the same school, by having this exposure to many different things, you see that these opportunities are something that is achievable. So then you start to see how each layer in my city, in my SDG, in my urban system is a complex system itself, okay? Each of those things is a complex system, but each of those things is coupled together with the other one. So you have multi-layers. So whatever you do here in the transportation system is going to affect this other one. So how do you make sure that all of these things that you're moving around are going to benefit most and are going to affect and drive the system towards the solution that you want? And then as you affect and change the system, you create an emergent phenomenon, right? But this one fits back into the other one and fits back into the many different systems. So you just start to see how complex all this is with respect to be able, not only, so we have experts and you have met many experts in transportation, experts in land uses, experts in economics. We have fields, we have disciplines related to all of these things. So people are very knowledgeable with respect to each of these layers. But what is the Holy Grail? How do we couple these layers? How do we make sure that when we are talking about, growth and we're talking about these things, we're not leaving people behind, and we're also reducing inequality and all these type of things? How do we make sure that as we put new infrastructural system, we have more regional access instead of just putting, like we will say that London is like the black hole in the UK and things like that. So the problem, I have to say, I bring more problems than solutions, but it's really food for thought. So when you're all familiar with the SDGs, you're all familiar with all these 17 different sustainable development goals. And of course, you see them all with their colors and all that. And it's very easy to see how, for example, if you wanted to tackle the number 8, which relates to decent work and economic growth, you cannot do this without education, right? So how can you ensure decent work? How can you ensure economic growth if you're not inputting education into your system? Or in the same way, if you think about clean water and sanitation, how you can think about that without reducing inequalities? And how can you reduce inequalities without economic growth and without decent work? And how can you do that without quality of education? And you can still you can now see how all these SDGs will light up like a tree. You need them all together. You need them all connected. And of course, it's a huge, huge task because you need to start somewhere. You cannot imagine, you cannot create a model of all of these interacting together in order to be able to do one, but you can start to think about how to start coupling pairs and how to then introduce another aspect and how to be conscious that in your models, you're introducing biases. Why are you introducing biases in your models? Why do you think this is the case? Data. Yes? You wanted to say something?
I think everyone has different assumptions on how systems fail.
Exactly. First, the assumptions. That's very, very interesting and very important. You have different assumptions, and because you have different assumptions, you collect data in different ways. And then you have assumptions of how your data is collected. So all the models that you're bringing together are going to be biased, okay? So you need to be conscious that this is what you have, and how are these biases being introduced into your different models. So overall, what we have is that the SDGs are really the outcome of emergent behavior. We didn't want poverty. We didn't want inequality. We didn't want any of these things, but we created all these problems. So how can we then drive the system into a different behavior, into a different emergent pattern? But then we know that because we have limited data, because we have all these biases, we know that, for example, informal settlement, we don't have these data set. You have to go in there. You have all these limitations. And also, most importantly, because you know that once you affect one system, you're going to have effects, non-linear effects into another one. You know this is going to happen. So you cannot really predict how, once you switch on one system, how is it going to go and cascade into all this other system? So there is limited predictability into your models as well, okay? So what can you do then? You create scenarios and you test the sensitivity of your parameters. Is it, once I have enough mass, enough people, will I have something else? Yes. We have agglomeration economies. You need enough mass in order to create more than proportional to people, okay? So we know that exists, but what is the threshold, okay? So you create your models, you start moving around, and you start to see what happens, okay? And so that's on the one hand. So all you can do is create scenarios. You cannot really predict that by doing this, you're going to achieve that. You can say, by doing this, you are moving towards this direction. And these are the scenarios that I can present to you in order to more or less see what is the best and what are the risks in all these cases. And of course, because you have all these many different interactions, the Holy Grail is how do you couple the different systems? So what I'm going to illustrate now is the coupling of the social and infrastructural system. So it's more of a small effort toward trying to link together all these different things, okay? So of course, I don't have a solution, this is what we will all want, to be able to know what happens once I do this, how do I obtain these other things? But how do we take into account the different aspects that might be available out there. So the first example that I'm going to go through is the problem of water that we have in Mexico City. So the problem of water in Mexico City, it's a huge one. Okay, so we have managerial problems, we have infrastructural problems, and also we do not have the funding, we don't have the budget in order to be able to fix all the problems at the same time. So what is it that we can do? We can create a small interventions, decentralized interventions, in order to try to more or less help towards this problem. And in addition to that, you can think about what are the other problems that the lack of water brings into the city, right? So for example, what is the social context? Because of course, once you have this type of problems, it's always the more disadvantaged people, that are suffering from this consequence. And so here what I want to show you, if you're interested into this project, you can go and click into these things and then explore, more details about the project. But more importantly, as I was saying in this slide over here, we have experts, okay, in each of these areas. So one expert in this area cannot understand the whole picture, okay? One expert in this other area cannot understand the whole picture. We have to come together in an interdisciplinary way in order to be able to bring ideas and frameworks from the very different disciplines. So in these pictures, what you can see, we have another scientist, we have a physicist, we have architects, GIS experts, plus all the social scientists that were in Mexico that I didn't have pictures for them here. Okay, so the first thing that we have is how are you going to then create any type of interventions? So on the one hand, you have the problem of water, infrastructural and so forth. And on the other hand, you're going to bring also all the social aspects, okay? So we're going to bring together what we call the water stress index and the adaptive capacity of the system. One is related to everything that has to do with the aquifer, the amount of water that is in there. And the other one has to do with the economic capacity, but also with the physical resources that you have in your system. So how are you going to bring all this together? And this is really food for thought. So this is I'm going to discuss this later on if you ask me a question. I give you there something to ask for later. But the whole idea is that you're treating these two things that are coming together. So what sort of mitigation strategies can you bring to something like that? One of those is constructed wetlands. So this thing, basically, what they do is that they clean the water and also they create flowers and all these sort of things. So you can sell these things, so you can create jobs in addition to cleaning the water that you have over there. But in order to be able to put this, first, you need education. So you need to educate the people of how to use these type of things, and also acceptance. So then you can go back to your idea of creating, like your new startup, like how I'm going to then diffuse knowledge in my system, right? So I need to consider how my communities are connected together in order to be able to do these type of things. So I need to understand where I'm going to introduce these things. It's not going to be just at random. I need to diagnose the system. And I know that by diagnosing the system means that I have to be very careful of all the layers that are interacting. And then I need to understand where is viable in order to input these type of things. So problem number one. I come from Mexico City. This is my city. And what is called Mexico City, it's only this boundary here that has 9 million people. If you have heard about Mexico City before, you will say, no, not 9 million people, more like 22 million people. Yes, I will say, and I grew up even outside of these boundaries, so to speak. Okay, so the first thing the first problem we encounter is that when you think about metropolitan areas, what you have is the core of the city and all the other settlements from which people commute to this. Yes, while in reality, so you will have, for example, who lives here in London? Okay, so a few of you live in London. So London has a green belt. What does it mean? It means, or in the UK, for that matter, who lives in the UK? The same. Okay, so the rest of you, where do you come from? All right, okay. So here, for example, we have a boundary, like a circle, like a belt around the cities, and it's called the green belt. And it tells you cannot construct beyond this green belt, okay? So you will have a contained city because, it has been input, yes, by policy. So you cannot build beyond that. And so what is it that you will consider? You will consider your city, the core of your city, and all the places as a metropolitan area from which people commute to work. And that will be like the definition of a metropolitan area, one that you would find as well in America. When you see a picture like this one, you realize that actually there is a continuum of people living. You don't have this idea of a core and people commuting from little settlements, from Kent, from all of these places here in the UK. Okay, so you will see here you will have your city, the green belt, and then you will have, from all the settlements from which and small cities, villages from which people commute. So we are faced with this definition of cities. What do we do? Well, take the metropolitan area. Well, it's too much. We cannot take the full metropolitan area. We want a minimalistic extension of our city, considering what we said before. If we are to do an intervention, we want to know who needs it the most. How are people connected? So we want the most connected core of what we can talk, where we can consider our city. Okay. And maybe you will see how in many of the cities that this is the case. So might have many extensions, but what would be the most connected core from which I can think about the diffusion of these technologies, for example? Okay. And thinking about this new definition, where can it be implemented, right? So where can I put this type of interventions that will be accepted? So how do I extend my area? So I consider that connectivity is given by the probability of interactions from individuals, okay? So how can I consider the probability of interactions? Well, my network is the one connecting people. So if I take the street network, I will take that the probability of interactions relates to people being able to go from one place to another. If the place is very far away, I'm going to assume that people are not able really to go from one place to another. If the place is very close, I'm going to say that this is the case. So if I apply something like that to my city in Mexico, I have this. So what is this? So let me guide you into what is it that you're seeing. I'm color coding by red as the largest cluster of connectivity in my system, and then all the other colors are the next biggest ones. The ones that are in gray, you don't see them really, but they are also connected clusters. So what I want to show you there is that if we were to say that a disease is to spread in the system according to how close you are to individuals, this is how it would spread if the proximity was given by the road network, okay? And then you will say, how close you are, like how many meters are you talking about? Yes. So it's not a unique set. I'm going to explore the whole threshold, okay? So I'm not going to give only one set. I'm going to explore many different distances and see when all of a sudden I have, for example, a jump into this core of the city connected into a largest one, okay? So depending on the threshold that I'm going to consider of connectivity is the sort of diffusion that I will get in my system, for example. But then we're talking about, okay, Elsa, you're saying proximity. Yes, I believe this can be good, but it's not always the case. If you think about the probability of interaction is going to be given more with respect to whether I'm going to interact with somebody that is similar to me or not. So we're going to think about the homophily principle. So I'm going to interact with a neighbor that looks like me, okay? What does it mean that looks like me? How do you know this, right? In your data, you don't have this, right? You don't have this person looks like me and this person doesn't look like that. So how do you construct these type of things? So what you can do is to take your city, you have your census data, and then each of these points in your space has characteristics. According to your census, it has, like the level of education, it has the income, it has many different characteristics, okay? It can be language, it can be ethnicity, it can be many different things that you have over there. And so you compare from each pair, my closest neighbor, you know, so you create a spider web. So are you a computer scientist or what's your background? Sorry? Okay, you're a computer scientist. Okay, so you create a Delaunay triangulation. I don't know whether you're familiar with this. Yeah, like a spider web, no? Yeah. And this sort of thing, it can be, did it make you think about something, this one here? You're a computer scientist, right? What about DB-scan? Hierarchical DB-scan, okay? So this is the same as a hierarchical DB-scan. And instead of cutting the tree at only one threshold, you're allowing the whole dendrogram to appear and you see how each of the levels is related to the next one, yeah? So here you have your vectors. So if you're a computer scientist, you're familiar with your vectors, and you can create a cosine similarity or any other type of similarity between these things in order to be able to see whether my neighbor is similar, to have a degree of similarity, okay? And you can repeat the same thing. So now, instead of doing your DB-scan, you know, your DB-scan runs on the network. It doesn't run only because in your DB-scan, you create a circle and you see who is around you. Instead of creating the circle, you only allow it to happen in your network. And then they all live. Okay, that's fine. So what happens next? You repeat the same exercise, yes, according to the proximity on the network and according to the homophily principle, okay? So the sociodemographic proximity. So you have two things. You have the physical proximity, and then you have your sociodemographic proximity, yes? And what is it that you observe? So what you observe is that actually these places that I have here in circles are the places that were left out of the original definition of my city, yes? These places were left out, and nevertheless, these places connect straight away into my system from the proximity of the connectivity of the road network, but also the sociodemographic proximity. Okay, so what are these places that I was leaving behind? So the red places that I have there are the places that I was leaving behind in my original definition of cities, and that I now need to add because they form absolutely an essential part of what would be the core of my city, because they are so connected from the perspective of the sociodemographics and from the perspective of the infrastructure of my system. So if I look at, for example, this bit here, yes, this bit here is called Ciudad Netzahualcoyotl. Ciudad means city in Spanish. And Netzahualcoyotl doesn't matter, it's hungry coyote, but that's not really important. What matters here is that this place here is this. So do you think this is a wealthy place? It's not a wealthy place, okay? So how can you leave behind a place like this one when you're thinking about a mitigation strategy related to water resources and so forth? And in addition, this place, so because you come from India, you won't be that surprised that this place has 1.1 million people, only that place that we were leaving behind, okay? So of course, it's something that needs to be introduced into the system. I invite you to look more into this app if you're interested into how you can assess, taking into account the whole space, the socio-hydrological vulnerability of the different places. And you can see that actually the one that we're leaving behind are parts that are vulnerable. I'm not going to delve into the details of then how you assess if you have a limited budget, where you're going to put your intervention. This is something for you to explore in these other things. So am I running out of time? Yes, I should hurry. I think I lost track of it. Okay. So very quickly then. So here what I said, and I really invite you to think very, very closely about all this approach related to creating indices, because this is something that you will find a lot in all the SDGs. these indicators, okay, they're not really interacting. So what we're doing is to take all these measures and trying to combine them in an index, okay? How do you combine them? How do you take into account the nonlinearity of it? So normally people weight them according to what is more important, and another one is this the right way? This is the way that most people do, okay? But this is something to consider, that it might be it's not something very scientific to think about, okay? So can we think about combining all these different things in a different way? So one way, for example, is this idea of multi-layer approaches. So you saw on the one hand that you have these many different layers in your city. So can you think about the different layers in your city so that they interact? As such, you take them, you look at the dynamics of each of the layers, and you couple them. Okay, so how can you do this? So this paper, for example, what it does is, if I'm going to put a new system, you know, a smart grid in order for energy supply, I'm going to be in the contract if my neighbor goes into the contract, okay? So how this is going to spread into the system relates of whether my neighbor or not, you know, whether my network, my community is also taking part of that. So what we did here is the spread on the one hand on the layer of the community. Which community? We take the street network again. So this is one of the biases that we're saying that you're going to interact according to these ones. And you know that depending on where you live, this is not the case, okay? So you need to be careful into how you introduce these type of things. And on the other one, you have the infrastructural layer, and you couple these two things. So I invite you to look at that. And the final thing that I wanted to tell you, so this is just a couple of slides, relates that this interaction, so we're talking here about coupling different levels, but we also have that the feedbacks not only go with respect, so how, if you change behavior at the local level, you want to know how this behavior is going to spread at the city level, how it's going to spread at the regional level, and so forth. Or if you have funding to put an intervention at the regional level, something happened here. Oh, but I think it's only here. Oh yeah, sorry, yeah, it's the people online, if there are people over there. I don't know whether you're there or not, but you can still see it. So we have also the interactions across scales. So you want to drive the system how? You can put an intervention at the regional scale, and you want to know which cities are going to benefit and how it's going to trickle down. But also from the local interactions, from the local behavior of the individual, how is it going to spread to the other areas? And this is an example to think about, for example, kind of economic outputs. If you want to inject money in a region, it really depends if you have a polycentric kind of region. So if you think about maybe Leeds, maybe you would think about it as a monocentric city, but who are you with respect to your economic opportunities at the regional level, right? So trying to bring together the different scales, not only from your neighborhood, the city level, and the regional level is something very important, and the global level. If we go beyond now with the SDGs, you can see how, you know, this starts to accumulate. Okay, this is my last slide. I promise. That's very important. Okay, so this is something to consider. For example, here, if you're in London, you will see that London is a monocentric city, monocentric region, right? Okay, so the last slide here, the role of digital twins. So we are talking about technology, and we're talking about all these things. We're talking about all the different biases of the model. And so finally, we arrive to what is, you know, like everybody wants to do. It's a digital twin, okay? But what is the main issue with the digital twins? First is that it cannot be only a collection of data. Yes, it can never, ever be able to reproduce completely reality because it has already changed. And because you have, what do you have? You have the feedback from all the different systems, okay? So it's very important to take that into account. So how you couple the different systems, how you have some scenarios that then will feed back into your models and so forth, okay? So even your digital twin, it's something that is dynamic and is not, like fixed, okay? So you need to consider how the new scenarios, when you change, is going to feed back into your models as well. And this is a new paper that came out last week. Okay, so to conclude, the takeaway messages that I want to give you is that each SDG is a complex system, okay? And as such, interdisciplinarity for each of those is necessary. It can never be looked from one specific viewpoint, but don't worry. It's I think I have never been in a talk with such dynamical public going in and out, It's of course, the SDGs aren't independent, okay? So think about how to couple them, not only with respect to them, but also the different scales. What does it mean you have different scales? We already saw that, but something that I didn't mention is the different dynamics, okay? So if you think about population, migration, the flows, the changes that you're going to have into your infrastructure and the flows of people are completely different dynamics, okay? One is going to be very slow and the other one is going to be very fast. How do you consider and take that into account? And you cannot predict wars and you cannot predict many of these things in order to take into account on the inflow. That's why you create your scenarios, okay? And so while coupling system is a very, very difficult thing to do, we really need to consider the different sociodemographics aspects that come into each of these layers that we can do, okay? It's very difficult maybe to couple of these other ones, but we can start making an effort and we can introduce the sociodemographic aspect in every of the different layers that we are looking into that. And of course, as I said at the beginning, we need to be very aware of the limitations and the biases that we have introduced in our models. And the only thing we can do is to create scenarios because we cannot predict the future. Okay, this is all. Thank you.
Thank you. All right, we have a question.
Okay.
Yes,
Yes, go ahead.
yes, so thank you very much, very interesting talk. And the question, I've got two questions. The first, just when we talk about digital difference, when we talk about digital shadowing, our problem is the data that we've got is just from the modern cities, not from the poor cities, because we don't have the infrastructure. So
Yeah.
any suggestion for that? That's
Yes, I think this is the most important problem of all that we are facing. So, for example, something that I didn't tell you when we did this one is that we had informal settlements over there. So, if we have informal settlements, which data are you fitting into this? So, what we did here, which is incorrect, yes, but is the best we could do, is to put the average of all the surrounded one. That will be like a projected scenario of the future. Of course, what can you do? Then you start thinking about satellite images, then you can start to think about going there and trying to take the data as such and working with all sorts of things. So you start from somewhere creating, a proxy, and then you start refining your proxy. So for example, when you don't have income data, I know now for Lebanon it's very difficult to do something like that. I was just there, but in other places you have, for example, electricity consumption and things like that. So you start to try to think about proxies in order to be able to compensate for the lack of data. But it's absolutely essential. Yes.
We are doing the project now, and we are basing our model on the data that we have here in Europe, but when we would like to apply to Malaysia, for example, or South Africa.
Yes, no, it doesn't
we
work.
have the data.
Exactly.
Maybe, yeah. Any suggestions?
Yes, well, this is the thing. So for example, flows, this one here is based on real flows of individuals. So we know how these cities come, but you can create spatial interaction models that I taught in this exact classroom last term. They were all sitting there listening the spatial interaction models, yes, of how you can create then, what is the highest probability of one person going from this other one. So in the end, also you end up having proxies, models for these proxies, because you don't have the data. So it's the best you can do, really. Yes, satellite images, so for example, remote sensing, in order to be able to know which are the places that have less, that are not captured.
Another question.
I understand from your presentation. Education is quite flexible, you can do a lot of things, but I want to understand how you try and get stakeholder buy-in, drive out competences or
Stakeholders. Yes, this is very important. Yes, because of course you see all these things and you see this formula, and this is not something that you will bring to stakeholder, because you will lose them in the first slide. I bring it here because it's an engineering kind of place, and I know that if I put, so what is this formula here? The computer scientist on the back. The computer scientist on the back. What is this formula here? No, but what is it? It's entropy, Shannon's entropy. Yeah, Shannon entropy. Are you familiar with this? Yes, you should be. So that's something, that's homework. Shannon entropy, very important. Shannon entropy for your studies. So let's go back to stakeholders. So for example, when we were constructing these indicators over here, there was a workshop. I wasn't involved on that. The social scientists were involved on that, in order to be able to see which were the main problems in the area, because depending on the local area, so you have to put context into place. And that's where you have the stakeholders having a very important role. Context, and be able to really point into the main problems that are there. So how are you going to weight all these different aspects here? How are you going to weight them? It's something that you co-create with the stakeholders. And then once you have a diagnosis of your system, okay, which is over here, so I invite you to log into this, then you will be able to together with the map to say, if I have small budget, where should I put, my constructed wetlands? And then it will show, like in your map. So I don't have it here, but it will show in your map where. And so you can then engage with the stakeholders via maps. I have to say that this is very important. This type of things in which you have the different sliders in order to engage with maps, with stakeholders, and be able to visualize. Visualization is absolutely essential to be able to engage with people. I mean, me as a physicist, I normally have a curve and that's it. I'm happy with it, yes. But then in order to be able to engage and be able to have more insights, you need something that is more tangible. Okay, so that's where the stakeholders come. So it's very important to co-create all these type of mitigation strategies and not to impose anything. Do you have a question?
No. I just got a call from IT. There is some issue. Please carry on.
Okay.
I'm sorry.
It's okay. Okay.
I understand that you have to get feedback. And you have all these models in place. Is there a way using the digital twin to confirm and improve the models? Data-driven.
Exactly. So we said we cannot predict the future, but we can create scenarios in order to see what would happen if we don't do anything. What will happen? We know climate change is going to come. We know more rain is going to come in more places. We know that less rain is going to come. And so how do you then use this digital twin in order to create these scenarios and to try to link how it's going to affect also other types of systems? So that's absolutely essential. So you cannot predict, but you can create scenarios to more or less have an idea where you will have a shift into your system. That is very important, okay? And that you can do. Yeah, in the same way that you see how the connectivity all of a sudden jumps from one place to another one, and that you can see. Yes, you can try to do these sort of things. I should go now, right?
No, I'm not here. Please, I'm so engrossed in that discussion.
So actually, I'm sorry to interrupt, but what had happened is because this is being also telecasted online. So I got a call from the IT team that probably the camera is off, so they're not able to see the speaker, and even the mic is off.
Because of we have changed the laptop.
Slides, but not the So I kind of interrupted. But it's all right if you want to just carry on like that.
But this is how you would say
No,
it, no?
but this is being telecasted live in India
Mhm.
campus, this thing. So since we have shifted the laptop, so they are only able to see the presentation.
They cannot see me.
They're
Oh,
not
it doesn't
able
matter.
However, your presentation was great. At least for me, it was very meaningful. The digital twins is an absolutely a very discussed topic these
Yes,
days.
yes, and it's important to say that, you know,
It's
you
really
cannot
good.
only do one and that's it, and
Mm.
reality, you really have to take into consideration all these other aspects.
Absolutely. Please have a huge round of applause.
Okay, let me stop sharing. Okay, I'm sorry that you couldn't hear me over there.
Come, yes, when they are the speaker.
The chappy voice.
Thank you very much.
Excuse me. I'll just check. Professor Suha, can you switch on your camera if you're there?
In fact, all of them are speakers.
Yes,
So,
I'm here.
Professor Sujata and
All the speakers, if maybe request you to come online with the cameras on. We are just trying to have a picture.
thank you so much, Dr. Sujata, Dr. Anjan, Dr. Neetu.
Mobinji, can you see that we can have all the speakers on the frame? Can you
Yes, yes, sir.
please? Thank you. Can you do that setting, please?
Let's make some settings so that
I think if you go down, then you'll be able to cover.
yeah, that's right.
उनको बोल दो कि अब चलो जाओ
I'm
अच्छा आप इधर ही आ जाओ कोई नहीं लेट इट बी लाइक दैट ये खाली लगेगा जाओ जाओ मैं खड़ा हो जाता हूँ यहाँ पे हमारी मीटिंग
Thank you very much.
आप फटाफट
Thank you, Professor. They were very nice. So you have to. Do you have to leave?
Yes, I have to leave. It's just because my mom is living.
Oh, I see. Yes. Hi. Now we go ahead with the presentation of the paper ID 83. Since that it's a time-bound thing, so we respect the time of all the presenters and will quickly try to manage your presentation within the time limit. You can be crisp in your presentation and the jury will be able to assess your presentation as well. I hand over the mic to the paper ID 83. Paper ID 83.
I thought the first one was number 4. Which schedule are you in?
I'm actually mixed up. It's mixed up.
The 83 is not on the schedule session.
It is the idea.
Hello everyone, am I audible?
Definitely, it's not.
Paper ID Okay, I will check with the area. Okay, that's how we want. You can let me know your
So the fifth one
paper.
is this. This is paper number 4, and this is online.
Yeah, so Professor
Yeah,
Suarez.
yeah, so
All right.
Yeah,
Let's go.
May I request Professor Soha to please go ahead with the presentation?
Okay, great.
I have your video. If you want me to, I can
Okay, it's fine. Yeah. Okay, it's fine. It works. Okay.
download it.
Hello, everybody. Thank you very much for having me in this conference, ICIEM. And I'm very actually excited to.
Is it okay, Professor Soha?
It's fine. As you like. If you find okay, it's fine with me. Both of them. It's okay.
That's a pre-recorded video.
Okay, so I stop video and mute myself here. Okay, but I can share it. I can share it if you want. If it's easier also for me. I can share the presentation from here.
Yeah, if you can share it, that would be
Yeah,
great.
sure. Yeah.
I'll just put this my screen on.
Yeah. Is it okay now?
Professor Soha, we have a campus out here in Berwick, and this is a time-bound activity. So I would request you to, if you can be very quick in your presentation. The jury is here, the IEEE members are here, and I will appreciate your help in this.
Thank you. Yeah, sure. Hello, everyone, and good evening. Actually, now it's like almost here 8. Thank you for all the organizer here with the ICIEM 2023. Thank you for inviting me, and thank you actually particularly with the IEEE. I'm really very excited to be with you. Thank you for Dr. Muna, thank you for Dr. Nagam for facilitating this presentation, just to present it today. You know, my article is actually about the artificial intelligence-based chatbot for promoting equality in high school advising. You know, basically, I'm passionate, you know, with using the technology in enhancing the education. I believe that education should be for everybody. Here, you know, I'm gonna focus here in the goal number 4 for the Sustainable Development Goal 4, which states that to ensure inclusive and equitable quality education and promote lifelong learning opportunities for all. Here, why high school students? Why advising students? You know, basically this is important because I think we have from the audience students right now, and they can exactly know exactly why this is really important. You know, this is in high school. This is the most crucial stage in students' lives. Students in this age, they can shape their future career with their passions and interests. It's a stressful time. Why it's a stressful time? You know, students in this age, you know, there is a couple of standardized exams such as SAT, AP, A-level exams. You know, some students are interested to study, for example, medicine, and they have to prepare themselves for the UCAT, and you know, this is gonna really stressful for them. What they gonna do? What's the solution here? The solution is having academic advisors. Academic advisors, sometimes, you know, we call it for as college career advising. We call it as college career advising. This is the solutions, you know. We should have college career advising for students to guide them toward their success. Student advisors, they are the main source for higher education career information for both students and for families as well as like parents. According to the American School Counselors Association, the main task for academic counselor is helping students to succeed and assisting them to assisting them to plan their career effectively. Okay. Now, okay, what about the disadvantaged high school? You know, this is, okay, what are they gonna do? The disadvantage to this school, that the unprivileged school, that they cannot afford hiring college career counselors or advisors to assist their students, to guide them. And, you know, if the students are not guided well, they would not be able, probably prepared for colleges, for their futures, for selecting their majors, for selecting the universities. So we come up with the objective here, or we come up with this solution to develop a novel, affordable chatbot by using a neural network and deep learning with the NLP technique to assist the students in high school. This technique, or this chatbot, it works by understanding and identifying the students' intentions behind each questions and request, and then they classify it by a particular class or tag, and then for preparing it for the further processes. What's the significance of our study? We have here the 3 main significance. For developers and the application developers, mobile app, they're gonna use this technology. The family students, they're gonna assist their kids. And schools, that supporting these schools, the disadvantaged high schools, with using an affordable advising chatbot. The conceptual framework here, I don't want to go more details about this one. You know, this is here the main structure of the chat, but this is the main component, NLP, NLG, the dialogue management, and the knowledge base here, the data. The software here, the tools that we use it in this chatbot, we use the Anaconda version 2.03, the Jupyter Lab, as well as the Python language. The experiment here started with these, the main steps here. We started with collecting the data with the corpus collections, creating the dictionary, pre-processing the data, and then we annotated the data that we collected. And finally, we built the model. Here, let's go with the data collection in quick, collecting the data. We collected here in this experiment or in this study, 968 inquiries and questions. We collected from different resources, from high school and universities websites, from schools advisors, and counselors. We asked them a couple of questions, and as well as from the students, web media, social media for students and blogs. The students, they asked some question, and we're gonna collect these. We collected these questions. Creating the dictionary, we used like some functions in the Python, like split functions that can tokenize and indexing each single words. And then we have here 1,115 unique words, and we put it all as a dictionary. The data pre-processing, we started with the cleaning data, removing stopping word, normalizing, and tokenizing the word as any text for pre-processing. This is the normal. Here, I want to give you a quick here about the data. We have it here. The data is classified as you can see here, that the 384 here for high school inquiry and 584 data from universities inquiries. Just here, I give you what does it mean for high school. The students sometimes, they ask, they want questions about, what's the A level, should I pick it in grade 11 or in grade 12? What classes? So this is the system or the chatbot. They're gonna categorize this question to the label 0 or high school inquiry. And in the other hand, if the student, they ask what the requirement, for example, for University of Liverpool or for University of Queen Mary. So here they're going to categorize this question to the other code or to the code 1. Here for building the model, I don't want to go in details about this model, and this is here in the right side. This is exactly what we did in this paper. We use the LSTM layer as a long short-term memory, because this, layer is gonna remember for long sentences, and they're gonna categorize, and they're gonna exactly remember the last words and the words, even if we have like long sentences. For example, here I have an example, like I want a financial aid. If you can see here, each letter, each word has a change to has been converted to one hot encoding vector, and then we feed it to the embedding layer. In order, the embedding layer, maybe most of you do know, the embedding, the most important or the most purpose of the embedding layer, that it's going to reduce the vocabulary list, and it's going to increase the efficiency of the model. And then we feed it to the LSTM layer, and finally to the sigmoid function in order to classify the words based on the probabilities. The results here, as you can see here, the table, here we use we kept tuning the hyperparameters in the LSTM. The hyperparameters, as you see here, the epochs and the LSTM neurons and batch. We focus in the neurons of the LSTM. If you can see here, we use first the 5 neurons, and we can see the accuracy is like 95.8%, and then we increase the neuron to 8, and we see here the accuracy increased to 96.5. And here on the right side, we see here an example about how does it work, that it can understand the student's language. For example, the student here asks questions like, for example, I'm interested to study abroad in USA university. The chat would say, yes, I can understand your question. You are asking about universities or colleges and etc. Any question they're gonna understand and classify it based on the probabilities of each year words. Finally, here, the discussions and the future work here in simple words, the Sustainable Development Goal, number 4, aims to ensure inclusive and equitable quality education and to promote lifelong learning opportunities. Students play a significant role on improving the quality of life by using their education to solve the world's problem. Really, I like it. It means a lot for me. That's why we have really to appreciate, the education and all the technology that really work to enhance the education, and because, you know, with education, we can solve the world's problem. College career advisors have an essential impact on student success and development. The disadvantaged high schools have a limited budget for hiring advisors, and we believe that education for everybody. That's why, you know, it's come up with the affordable chatbot that's going to be implemented by using different technology. What I use here, the neural network technology with the NLP. In future, what I'm going to do, and I started already working now with the having like a stack of layers with the LSTM, and just and definitely we're going to use another function, which is the softmax function as the output layer, because we're going to have different classes, not even 2 classes as this study. Thank you very much. Thank you. I really appreciate you, and appreciate all, you know, all the effort that you make it just to make this presentation successful. Thank you very much.
Thank you.
Thank you so much, Professor Soa. It was a delight to hear from you, and thank you that you abided by the time. Any questions from the audience and from the panel team, please? Do you have any questions? If not, we can go ahead, and thank you once again, Professor Soa.
Thank you.
And in the sequence, can we go ahead with the paper presenter 2? The professor, yeah. That's a poster presentation although, and but we have it on our system, and I will put it across the audience. This is the children's right to play. Is that the one? Right. All yours. Please go ahead.
Thank you so much.
Need any help?
That's fine. I just want to. Awesome. I'm from a very small town in South Africa, and when I heard this morning about all the privileged students that are here doing all these engineering courses, my heart went out to the continent of Africa, because all these collaborations between India and the UK and America and Switzerland, and then I think of who's going to look after Africa, who's going to look after all our problem solvers that's there in South Africa. So where I come from is literally in a small town. I, this morning, for the first time in my life, had to navigate trying to get onto the system and trains. We don't even have a public system where I come from. So there's a big population out there that is not forgotten, but if we don't look after them, all the progress that is made across the world is going to be null and voided, because there's a big population that we need to look at. Now, where I come from, I work with children in rural areas. And one of the things that I've done in my research for the past 35 years is to monitor how children play. And I work cross-culturally. We live in South Africa where we have 11 official languages. So just to play with children and work with children, you don't even have the luxury of playing with them in their own language or talking to them. So you need to use another medium of dealing with them. And that's where the whole thing came up over the years, that I needed to start working with play. And I started working with the traditional play methods, your puppets, your storybooks, your board games. And then you realize children are born problem solvers. You just give them things, they build things, they solve problems, they make things move. And then the question is, somewhere the education system then fails these children, because we don't see these children ending up in universities. We don't see these children are ending up being engineers, doctors, problem solvers where they need to be. So the question is, how can we turn this around? And in my research, what I've then done is to say, but we need to do something else. Now, I'm a registered educational psychologist specializing in developmental psychology and how the brain works. And what I then realized is, over the years of research, is we need to start when children are young. We need to start between the ages of birth and 12 years old, when the brain still has the neuroplasticity. And if we want to have optimal brain development, optimal problem solving, we need to do it when the children are still very young. And when I look at play, I want you to think of your traditional play, and that is your traditional play methods that they have in different cultural groups, your puppets, your board games, your stories, but then also your technology, and then what the future holds for us, our augmented reality, and then our virtual reality, and what we can do with that as well to make it accessible. The reason why we need to do this and see this as a matter of urgency, if we look at the world population and where we are going, there's a high percentage of children that is not going to be in a school system. We're talking about 258 million children that's not going to be in a formal school system. If we just look at South Africa and where we have, South Africa is one of the most unequal societies there is in the world still. And that's for the rest of Africa as well. So we have, because of the education system that's very poor, we have a very high unemployment rate. Because if we have a very high unemployment rate, we have very high crime statistics as well. We only have 65% children in grade 3 that have got the literacy rate that is necessary to be able to go into the school system. We look at the subject mathematics. Now in South Africa, 73% of our children take maths literacy. That means only 28 out of 100 can go into a career in the sciences, medicine, engineering. Out of those 28, 50% do not go into those careers. So that means only 14 out of 100 will have the opportunity to become a scientist. 50% dropout rate is there in the first year due to maths anxiety and study orientation towards maths. So we in South Africa are not producing enough STEM learners to meet our national development plan that was set for 2030 as well. That is just South Africa. The rest of Africa has got the same scenario, if not worse. So when we look at play and when we look at embarking and playing with children and using the medium of play, then we're basically looking if we can change quality education, reduce the inequalities, gender equality, if we go and look at how many girls are not going to be in a school system. And some of the statistics are from countries like Australia, which you would say is one of your developed countries. Then you see that 9 million girls between the ages of 6 and 11 will never go to school. So the problem is much bigger than we can ever anticipate. If we can get our girls back into society, if we can get our girls back into leadership positions, they can make decisions that are good for girls. What sometimes really gets to me is that we sort of like say, thank you for men for thinking of women. It should not be like that. It should be, the goal should be, we should make decisions. We should not ask that men should take us into consideration. One of the other things, if we look at the mental health being, is how to develop resilience, how to develop emotional intelligence. And again, we need to do it through play as well. So in my own research and my own innovations that I've done is we came up with a program which we call the Wartels, and we use it in our Let's Really Play Math centers. And that's one of the trademarks innovations that we're now running out. And what we do is we use our traditional board games, we use our technology, and then we are busy now with taking the data so that we can see what happens in every rural area, so that we can give the decision makers and the policy makers the real-time data of what each and every community needs. And when I was looking at the previous speaker's model that they were talking about is how can we then have a model to then say this is what the data is saying, so that we don't give every community the same, but we give every community what he or she needs, because we will be able to see what each child does individually, we will see what a group of children can do, and we can see what a community of children can do. So imagine if we can have that data available for the whole of Africa, how much better we can spread our resources as well. So there's a lot of challenges when we look at technology in terms of, is it good for children in terms of their cognitive development? What is the opportunities for that, physical, the social environment, the interpersonal skills? So it's not about whether the one is better or the other one. It's how are we going to use them in conjunctions to get the best and help our children play. And for me, the end is how to develop engineering habits of minds from a very, very young age. So my own invention, the Wartels innovations that we have, we use our storybooks, we use our puppets, we use our board games, and now we're implementing technology. And the next thing, we already have the augmented reality available. And what is very important, we connected it with continuous research with the Loughborough University. We got a Royal Society grant. And from the data that we're gathering, we will be able to see how does children in different cultural contexts play? How can we incorporate play in technology, augmented reality, virtual reality, so that we can still get every culture to say and get the data that we need at the back as well. So that's in short. Yes.
Technology, what's the right, and in your opinion, what's the right for your project?
For our project, we're already busy now with augmented reality. And then imagine the world, if I can take virtual reality and I can take a day in a life of a nurse to a village school, and I can have that, and they can literally go and put on the screen and then just move around and see what that looks like.
So that would be possible.
That will be possible. Yes. And that's the kind of thing, for example, if we can take that kind of thing and develop that and take it the world outside there to a village school, because the area that I come from, I always think of, we've got our 6% that have, and for them it's something different. But then if you take that to that Setlagoli village, and I can take something like that in technology and they can see. I mean, if I take the augmented reality examples that we have, and they just see the things appearing right here, and the little faces that lights up and that. I mean, I can bring the museum right there to them. Yeah.
For them, if they are like in a village, in a poor village, they never seen something like that. They don't know how to use this type of technology. So is there like a course or just...
Now that's exactly what, and if we look at Sustainable Development 11 is how do we get the community? So what we want to do with our project is that we want to empower, even if it's somebody just got a love for children, that we train them and then they go out and they go and take that, exactly, so that you take that package. You don't have to have a highly qualified teacher. You don't have to have lots of resources. You can just have a little center there or a little classroom. We've got at one school, we have a center there. So the children literally go to that one, and that's where they play. And we just trained one of the people who's got a love for children, and they expose that to them then.
To see your results.
Fantastic. Thank you so much. Yes. Say again. In South Africa, I was smiling. We, in the little town that I come from, we've been without electricity for 10 days. So that's the reality check. And that's why for me, the one play will never replace the other play. So it's always to have a backup. So that's why it's not the one at the cost of the other one. Is how can we implement this? That when we do have connectivity. But that's the question. If I can go and I can show with a map, like the keynote speaker was saying, that is where we need connectivity, and I can go to a Standard Bank or wherever and tell them, but while you're bringing this in, can we also have connectivity, or can we also have tablets, so that we can motivate and for what each and every community needs. I might not need tablets for that community, but this community, can we get a tower here as well and get MTN involved in that one as well? So that's the kind of thing that we're planning to do as well. Thank you. So, thank you.
Thank you so much, and Professor Petro. And the best part was you explained it very gradually. So even I could understand the students that was engaging enough for the students as well. Thank you. And going per the sequence, may I like to, I see that online we have Professor Sujata Swen, paper ID 45. Professor Sujata, you there?
Ma'am, paper ID 45 will be presented by the Dr. Anjan Bandyopadhyay.
So that you can share your slides.
Yeah.
Yes, I'm present here.
All right. Thank you, Professor Anjan.
Yes.
Yeah, you can go ahead and share, please. So this is paper ID 45.
Yes.
I request once again to you for you to be crisp and absolutely focused on the results. It's easy, it will be easier for the jury. Thank you.
My screen is visible.
Yeah, we are able to see the slide. The first slide is visible, Dr. Anjan.
Okay.
Kindly make it full screen.
Yes. Now is it okay?
Yes.
Okay. So I'm very happy to present my paper in this conference ICIEM 2023. So this one, just a minute. So this one is my topic is the medical education system based on metaverse platform, a game theoretic approach. Here we have to implement the game theory as well as the metaverse platform. Okay, so these are the contents of my paper. First one is introduction, potential architecture, literature review, system model, proposed mechanism, explanation of MVRAN, and the simulation result and conclusion. So you know the metaverse platform already. So metaverse means that the beyond the universe. So metaverse is a metaverse is a 3D platform that uses virtual and the augmented reality to create an immersive experience beyond the limits of the current devices. So it allows user to do everything from shopping to meeting friends, family in a more immersive way. The potential architecture for commercial perspectives of using metaverse by adding medical prospects can be several formats. So auction mechanisms are previously used in somewhere. Now we have focused on the metaverse in the medical industry to resolve some of the architectures. I'm coming to the point. So there are many models on this concept that do not require monetary aspects in the metaverse framework. So we are basically highlighted the metaverse platform where we can use and how the new coming doctors can benefit.
Professor Ranjan, we would appreciate if you can quickly go through the introduction part and come to the analysis or a conclusion.
Yes, coming. Okay. So this one is the potential architecture part. So here the doctors, actually there are so many service providers are there. In the first case, there may exist a medical students, that is the client, who wants to view multiple operations providers on the metaverse platform. Means that there are several operation theaters are there. So the newcomers doctors wants to means that they wants to see how the operation will perform. So they are giving some preferences on the operation theater. That is the main focus point of this research paper. There are many specialized medical students, clients, but there may exist only single operation provider to view on the platform. So we have classified into 4 categories. First one is the multiple operations providers are there. Next one is the single operation providers are there. Third one is there can be availability of the multiple medical students clients that correspond with the requirement of multiple viewable operations providers. And the fourth one is that there can be a medical doctors clients who are required to view multiple cases of operations, and the metaverse platform will provide heterogeneous facilities for the same. This one is shown in the figure 1D. So now coming to the literature review. So I'm now skipping the literature review. Now system design. So here this paper discuss the distribution of the surgical rooms among multiple doctors through a metaverse platform. where each doctor has an ordered preference for each surgery room. The set of surgical rooms and the doctors are denoted by R and D, respectively. And each doctor has a preferred ranking of the surgical rooms based on the type of the surgery provided. So here, the capital R represents the set of surgical rooms, and the RI refers to the ith surgical room where RI belongs to R. So D represents the set of all doctors that depends on the D1, D2, D up to DN. DI refers to the ith doctor where DI belongs to D. And this one is, the symbol is represent the they are giving, means the who, means that the doctors giving the preference on the operation theaters. So represent the set of strict preference ordering of all the doctors that belonging to the 1 to N. And I indicates the preference of the ith doctor over R. So here the proposed mechanism, here we have proposed a new algorithm. That is the name of the algorithm is ICIEM. Is it a practical allocation network method for doctors to allocate applicants in the best possible structured way. The method provides an incentive compatible way to justify the preferences made by the doctors. Here, every doctor, a doctor in DJ is not recommended by any user in DI union D2 and union DK during the first K-1 rounds of this algorithm. The allocated resources are part of the code, and the computer allocation is a part of the code allocation. So I'm coming to the example. So this one is the explanation of our algorithm. First one, you just see the right hand side figure. Here the doctors are there, D1, D2, D3, D4 and D5. On the other side, the operation theaters are there. That is the R4, R3, R2, R5 and R1. And in our algorithm, already D1 doctor already allocated by R4, D2, R3, D3, R2, D4, R5 and D5, R1. They are already first phase is that they are already allocated by a particular operation theater. Then the doctor try to improve their preferences, means that they are trying to go to the another operation theater. So they are giving the preferences. So in the second case, the D1, D2, D3, D4, D5, so 5 doctors, they are giving their best preference to get a good operation theater where they can visualize their 3D model operation with the help of the metaverse. That's our main motto of this paper. So here we have implement the cycle detection function, detects a directed cycle in the graph, and the agent removal phase removes the agent in the cycle from the available set. So here we have used the cycle detection, we have used the diagram creation. So these are very much applicable in our problem. Now the simulation results. In order to compare the social welfare achieved by our algorithm and random assignment, so we have compared with the random assignment algorithm, and we can get the better result because the data is not available now. Then we can compare with the other problem. So this one is the new dimension of the metaverse platform, where we can apply the the newly doctor can get benefit from their 3D view of the operation theater. So here the green average social welfare. So I'm coming to the result analysis part here. So first one is the graph shows, first graph shows social welfare due to our algorithm allocation and the decrease in social welfare due to the random allocation for 20 doctors. So our algorithm running with the compared with the random. So here we are getting the better result. Better result means that the doctor can get their preferable operation theater. That's the result. So we are trying to present, and we can find out the social welfare of this particular problem. Now compare with the social welfare with the our algorithm with the random algorithm. Now our algorithm is performing better than the random algorithm. So these are the simulation results. Again, we are comparing so many doctors are there and random allocation. And this is the conclusion part. In our paper, we have designed a more consistent and efficient method of allocating medical resources in the metaverse and proven that is gives far more successful results in comparison to random allocation. In our future work, we plan on taking facial factors into consideration for a more realistic allocation. That's all. These are the references. And thank you. Any question?
Questions, if any? All right. So we move forward. Thank you so much, Dr. Ranjan.
Thank you.
Yeah. So maybe please move forward with the presentation from Callan. That is paper ID 49.
Thank you, everyone.
Agent-based simulation. Please come, Callan. Just and your, I think your, please help me in this last, this one. This is here. This is yours. Okay. Can you copy this so that I can be independent? Go ahead.
Sure.
Yep.
So today I'm going to, you hear me okay?
Yeah.
Today I'm going to present some work I've been doing with Babel, but it's all about agent-based simulation of botnet, volumetric and amplification attack scenarios on smart grid systems and resources. So I'm going to talk about what agent simulation is and the context of agent simulation, and talk about what the paper aims to do and the approach. I'm going to speak about what I've done for implementation and results, but then also look at some of the limitations of our implementation. So agent-based simulations are computational models designed to replicate patterns of emergence, and patterns of emergence are local phenomenon that can result into system behavior. So one example is birds flocking to collectively forage or travel. They obey simple local rules, and that has the appearance of flocking. And agent-based simulations have been used to model a variety of domains such as biology, cybersecurity, ecology. This paper presents, not read this all, but we do three things. One, we explore the context of botnets and FDIA attacks. We look at attack models, such as false data injection attack. And we also finally kind of recommend control mechanism to prevent cyber attacks on the smart grid network and resources. So in our simulation, we simulate household energy profiles. So that will be a typical workday and also weekends. We model 6 different profiles, so single pensioner household all the way up to households with children. Another component of our simulation is electricity markets. And this is where you kind of buy and sell energy, but it is quite simplified. So we simplified 2 parts of it. One is the retail market, where energy suppliers sell energy to households. The second is the wholesale market, where energy suppliers buy energy from demand generation sources like power plants. And in addition, we also kind of use that information from the supply and demand side to create supply and demand curves. And we kind of create a market clearing price, which basically kind of balances supply and demand. And we then use those two components to construct a kind of attack mechanism. And we kind of do this by botnets. And botnets are computers that are designed to operate autonomously without human control. And they're designed to send commands to another host to make them unavailable, particularly in DDoS situations. So I'm just going to briefly talk about common attack scenarios that occur in the smart grid resources. So one affecting availability of a service or an operational service is UDP flooding. And so what happens in UDP flooding is that hosts send a host, you have kind of two hosts in this example. A host can send a large amount of UDP packets to another host, and that can cause availability issues. The attack that we're going to kind of explore today is more around integrity, where smart meters can be compromised by injecting false data inside of them to misreport energy readings or to not report energy readings at all. So we model a variety of different agent classes, and these are just a list of them. So I'm just going to skip this in the interest of time. I'm not entirely sure if you can see this, but this is one of the attack scenarios that we have in our model. And it starts off having, you have your bot master agent and your bot agents, and they're connected to each other. The bot master agent can send commands to the bot agents. For in this instance, the bot agent would declare that like a false data injection attack is happening, would send that command to the bot agent, and we kind of assume that we find all the smart meter agents and we enumerate them, and the bot master agent sets a list of two variables. One is command repeats, I'm not sure if you can see it, and command targets, but these two control the number of resources that the bot master attacks and the number of times that command is repeated. So in terms of our results, we conduct sensitivity analysis. So I think the previous agent-based simulation presentation talked about a little bit about having a set of parameters and increasing them over time. In our particular case, we are looking at the average electricity price per hour. And this is just from the settings that I previously discussed. But we kind of, our general kind of observations are that at low intervals, when we kind of have low occurrences of FDIA attack on smart meters, electric devices, we tend to not see a lot of volatility in the average electric price per hour. But over higher intervals, we generally see that more occurrences of FDIA attacks do have an impact, and that's clearly seen from the data. So there are a little lot of them, but the main thing that I'd like to focus on is really, so we make a lot of assumptions in our model. So some of the attack models could be improved further. Do I have enough time or? Okay. So starting with the attack models, at the moment, we assume that there is no network communication between each agent. And so that would be one area of improvement. So at the moment, at present, there's no routing or latency or jitter that is associated with the packet from agent to agent. So that would be something that the future work could be extended to. Secondly, kind of agent behavior. So I'm not entirely sure if you can see on the screen down here, but in this like square box, there's two like instructions, and what you have in like the current implementation is that the kind of first instruction you give it. In this case, let's imagine it's like, I don't know, this is like eat cat and eat dog, and eating cat is first, but eating dog is second. So that kind of that inherent like limitation of like one before the other is also not a true reflection, due to agents can do multiple things at times, but in this case, it's only one after the other. So that's something that would be improved in future works. I'm going to skip to the security recommendations. So some security recommendations have come out with this. Just a brief outline. Them is just kind of have strong forms of authentication to prevent FDI injection attacks. Have some form of detective controls to inspect when an FDI injection attack is happening, and use data to try and understand the scenarios where there might be an attack happening, so that you can mitigate it or raise an alert. And just briefly on simulation improvements, there were kind of some inherent limitations with performance, just because when we designed it, we didn't account for the amount of data that was generated by the agent. Yeah, I'm gonna leave it as that. And yeah, just conclusions is just generally the kind of discussing the application scenarios, presenting the attack models, but also just we kind of have a general observation that large amounts of FDIA attacks can cause volatility in smart resources. But in the future, I would try and get more data to on smart grids and model stuff a bit differently, more realistically. But that's all I have today. Thank you for listening. Well, I don't know exactly on the top of my head, but I think it's something to do with infrastructure and industry, and and clean energy. That would be one, but I don't know. Yeah.
I wanted to ask, what is special about smart grid? Is it more vulnerable to such attacks, or why did you study the stuff of attacks within the smart grids?
So one feature of agent-based simulation is used to, so smart grids have a lot of scale and a lot of interacting components, which makes it a good candidate for agent-based simulation. I would say that modeling like amplification on the smart grid using agent-based simulation is a way to get an easy kind of read on like how vulnerable your smart grid is. I wouldn't say I'd be able to answer to the depth of that question, but I don't know if that answers your question.
Thank you.
Okay, cool. Thank you.
Next, please come. Yes, for the site, you can open it. You can use the mouse. You can separate mouse.
हमारा
So good afternoon, everyone. My name is Dua.
and my friend Pranav Garg is also here. So our topic is on self-healing concrete and its application in reinforced structures. So as you all know, concrete is the most widely used substance or material in terms of making any building or anything. But the main problem that lies with the concrete is that it has a very low endurance in comparison to tensile stress. So under high tensile stress, it has a very low endurance, due to which cracks open up. To counter this problem, steel bars are used, which is usually used to reinforce the concrete. But this still leads to some problems as prolonged exposure to the environment causes cracks to open up. To counter this, self-healing concrete is used. Self-healing concrete is nothing but basically a concrete which uses bacteria to fill up the crevices that occur. The bacteria that is mainly used is of Bacillus species. This bacteria reacts with the environment and releases calcium carbonate to fill up the spaces in the cracks. So that is that. So in order to select the best suitable self-healing concrete for our material or our building, first we have to select different concentrates. The three concentrates that are taken are 5 ml, 10 ml, and 15 ml of concentrate. They are mixed with 14 kgs of cement and with 6.5 liters of water. After this, the result that was obtained was that the best quantity of solution was 195 ml of 15 ml concentrate, as we can see in these graphs. So that is one method of making a self-healing concrete. Now my friend Pranav will take over and he'll tell about the second method.
Good evening, everyone. Now I'm going to discuss about the second method of making a reinforced concrete. With a water to concrete ratio, with a water to cement ratio of 0.52, it consists of calcium lactate and yeast extract that are vacuum impregnated into the vacuum impregnated in expanded clay, and then the test is performed and the result is obtained that
So basically, we conclude that self-healing concrete is a new future ahead, and it is mainly because it is more bio-friendly, also eco-friendly, and it has a more easier approach to use. It costs less in comparison to using external agents in order to fill up the crevices. So that's the main gist. Any questions? Yes, ma'am. Because the other alternatives that we used previously as they pollute more relatively, as in we have to use more cement or we use plaster or whatever, which again erodes over a period of time instead of fixing the problem permanently. It's not a full solution, permanent solution. It's just a short-term solution. Whereas self-healing concrete, on the other hand, is a more permanent solution, as the bacteria is is actually inside the cement. It's infused within the cement, and it only gets activated once the crevice is formed. So it is relatively more eco-friendly than using traditional methods that we have been using. Sorry, no? Sustainable goal is basically what happens is from the traditional ways, the crevices that open up lead to the lower life of the structure. It causes the structure to fall more easily, as we can see in previous bridges and all. But when the self-healing concrete concept is introduced, it leads to a lengthier life of a structure. So when we can say that it's more ecological in that way. so that it. Weather basically. That would only affect the activation time of the species of whatever bacteria we use, and there is not only a single bacteria that we use. It's a full species, so based on different applications, different temperatures, different environmental aspects, parameters, then the best healing concrete is made. Anything else?
Thank you so much. And thank you so much, the jury. I could see the next paper, which is online, paper ID 78, that belongs to Dr. Neetu Mittal. I'll just put this off. Dr. Neetu.
Hello, everyone. Should I share my screen now? Am I audible?
Yes, you are. You may please share your slides. Dr. Neetu, you may please share your slide.
Yes, I'm sharing. I hope my slides are visible now.
Yeah, you may increase the size as well. Yeah, that's great.
Right. Okay. Hello, everyone. First of all, thank you very much for giving us the opportunity to present our research work in this platform. So our paper is based on app-based implementation of modern agriculture utilities for the farmers. So first of all, these are the contents: introduction, review, literature review, methodology, layout of the app and present application, result, conclusion, and we have included the references as well. So agriculture actually has been proven as the backbone of the human civilization, and its significance has also increased in recent time as the world population continue to grow. So over the period of time, the technologies has plays a very important role to upgradation of the agriculture and the farming facilities, and it proven as the digital and analytical tools is driving the continuous improvement in agriculture, and the trends actually grows now days after days. So it results actually is that the improving crop yield and helping to the farmers community, the income of the farmers community, the facility of the farmers community at all. So the basic research actually for this, through this paper, we have focused on the how on the one platform can farmer be benefited. So here we have written also in the last one, the modern, just give me a minute. So that mobile app which we are which we have developed actually through our research. So this is developed it first of all in React Native, and its framework is totally based on the user friendly environment, so that the illiterate or not illiterate farmers can also easily use that in their smartphones, whether they are the iOS, whether they are the Android equipped mobile. So next we have the review of literature. So because of the lack of time, we are skipping that. So these are the literature review. We have done a lots of literature review and find out the gaps also. So now these are the methodologies. So in this methodologies, we have concept and design, front-end developer, back-end developer. We have testing phase also, deployment and maintenance and update are the important part, because as the based on the feedback and the updation has been done and the maintenance has been done for all type of farmers and for all type of users. So first we take one by one. So this is the our screen. So first we have the splash screen. So in this splash screen, actually, just give me a minute. Yes, in this splash screen, the display of the app or logo has been visible. So few seconds, the app has, after the few seconds, the app has been launched. One logo and some type of display has been done, and then the login screen, and then finally a home screen, And those home screens, some dashboard, tab, and notifications are there. So these are actually the pictures of login screen. And in this login screen, we can see that this is the dashboard and these are actually the tabs. And here is the registration form, or we can say the registration screen. On that, the farmer get registered, or any of the user get registered by themselves. And we can give the information, or that particular app can give the information accordingly as per the requirement or as per the demand. So these are the two actually, yes, these are the two forms by which the app has been visible. This is the dashboard and these are the tabs. So in dashboard, we have farming practices. Farmers can shop also. Weather forecasting facilities are there, because the weather forecasting is very, very, very important for the farming and for the agriculture purpose. So some recent updations on agri news, the app has been provided. Some calendars are there. Suppose we have grown some, we have bought some crop and for some particular time, and we have to sow that crop in some particular time. So calendars are also there. So if we want to go shopping, so through that shopping, some crop screens are there. The farmers can see the different type of crops. It can that app have given the crop details screen. So farmers can easily buy this crop through that screen and then check out that screen very easily. So this is the bifurcation, or this is the description of the dashboard. Then we can see here the tabs are there, like this home tabs, and we have lots of different tabs. So through these tabs, we have cell crops, profile screen, and chat screen. Suppose a farmer want to chat. So some experts are also there, expert facilities and expert advices are also there. Through the chat screen, farmers can take the help from the farmer, from any of the expert, agriculture expert, or we can merge it with the chatbot, or we can merge it with the chat GPT also. So that actually we are planning to do in the future work. But this time we have given some expert facilities by which the farmers can be benefited. So preview screen we have, and in profile screen, the farmers or any of the user can edit the profile. They can select the favorites. Contact and support systems are also there, and then finally the checkout of the screen. Right. So this we have already discussed. This is the login screen. Actually, this app has been implemented also, and these are the screenshots of the real app. So these login screen, register, and this is the dashboard, and this is the tab which we were discussing about. So we have done a simple demo with this app. So here we have the weather forecasting screen. We can see that, and this is the buying and selling screen which we were discussing. So welcome to the agri shop. So there are lots of different crops. There are lots of different fertilizers we have, and this is the description of those fertilizers. This is the calendar. This is the sales screen, and this is the simple profile. Right. So this is some benefits we have. Now we have the conclusion. So this app actually we are proposing this app to give the benefits to the farmer, as well as to give the benefit to the government, or to give the benefit, because this app may be the direct interaction between the government and between the farmers. So in middle persons can be avoided with this app, and the strong framework for creating a mobile application for selling goods has been also proposed, and in the very lucrative, or some offers are also there for these buying and selling products. So additionally, style enhancement to be improved, the user experience, server-side integration, and payment processing are all potential future developments are there with all these applications. So these are the references we have used with this app.
Thank you. Thank you so much, Dr. Neetu. You were quick and you were crisp in your presentation. And may I pass on if Jury has a question?
No, I just wanted to know whether the app is being used. Is anybody using it? Or is it just
Dr. Neetu, the question is whether this app is being currently used, or it has been brought into practice as
We
of
have
now?
just created that app. We have applied for the copyright for that app. And we are certainly, we would be trying to use that app with the benefit of the farmers.
All right, thank you.
Thank you.
Quickly going ahead with the second last paper.
Can I leave now? Sorry,
Yeah,
excuse me.
yes, thank you so much, Dr.
Thank
Neetu.
you, thank you, Forum. Thank you very much
For your time and patience. Next, we have Dr. Ankur Goyal. The paper ID is 11, a dimensions reduction analysis.
Good evening, ma'am. Can I share my screen now?
Yeah, you may go ahead. And I again request Dr. Ankur, it's a time-bound event.
Sure,
I
sure.
may request you to be.
I will be the fast, no problem.
Thank you.
First of all, I would like to pay my sincere thanks to Amita University London for providing me this particular opportunity. And I'm just, so the title of my paper is Dimension Reduction Analysis of Factors Influencing the Adoption of Community Cloud Computing in HEIs of Dehradun, Uttarakhand. So these are the table of contents, and I will move on to the introduction part. As we all know that adoption of community cloud technique is a very popular technique as far as higher education institution all around is concerned, especially in the foreign countries. We have taken the literature review from, especially from the Saudi Arabian countries, and it has been implemented in Saudi countries very well, and it has been very cost efficient, resource efficient, and very helpful in sharing of infrastructure. So we are trying to implement this particular technique in Dehradun. Dehradun is a city which is highly, which is highly dense with the higher education institutions, so that we can share the resources commonly. We are trying to find out the suitability of this particular technique in the Dehradun region. So for this, we have identified certain factors through the literature review, and we have applied the factor analysis technique through SPSS, and we have finally obtained 6 factors. This is my literature review. I'm not, just because of time consideration, I'm not following it. And again, moving ahead, this is the gap analysis. Till date, no study has been conducted in Indian context as far as adoption of community cloud computing is concerned. Research objectives are like this: to explore the various influencing factors related to ACCC in HEIs of Dehradun city, and to extract the basic underlying factors. These are the methods and materials. This particular study has been conducted in higher education institutions of Dehradun, and fundamentally we have selected like 21 fundamental factors from the literature review, and they has been subjected to 120 respondents, and out of which 100 are the valid respondents in Dehradun region. Sampling technique is convenience and snowball sampling.
Professor, could you please come to the result? I would appreciate.
Yes, I will be coming. This is my data analysis and interpretation part. These are 21 factors, and these 21 factors has been subjected to factor analysis technique through SPSS analysis. This is the initial part, KMO and Bartley's test. Then this is the extraction of communalities, which tells us that this particular technique is very useful, and this is justified technique for this particular study. And this is the component matrix chart. Once again, this is the total variance explained. This is something very, very important. And this is the final one. This is the final result in which, we have come to basic underlying 6 factors. And cutoff percentage was taken 0.75, and finally 16 variables were extracted in all, and they were subjected to the 6 factors. And these are the underlying 6 factors: factor 1, 2, 3, 4, 5, 6 factors that I will be covering in the conclusion part. My conclusion: this is the last one. The present study conducted that overall ACCC in HEIs is just at the nascent stage, being that all major studies and literature pertain to the other countries. Dehradun, the capital of Uttarakhand, India, is one of the most prominent hub of higher education in country. Hence, ACC would be an added advantage and overall effective for an HEI situated there. This study aids in streamlining the influencing factors that induce the ACC. The 21 factors has been explored, and total they are the 6 groups that I have already discussed. And this is all from my side, and this is a reference,
Thank
and
you.
I'm open for queries. Thank you, ma'am. Thanks a lot.
Thank you so much. And Dr. Goyal, I appreciate your time, your patience with us. I understand that it has been a delay for you from the India campus.
No
From the
problem.
jury,
Thank
if any question? I'm more thankful to the jury out here because they have extended all their help to us, and there were a couple of more papers, and they are helping us reviewing us that too. Thank you so much, Dr.
Thank
Ankur.
you, ma'am. Thank you.
And the last two papers, paper ID 100 and 103, both of them belong to the author Mohammad Shahzeb, who is there online. But here also there are a couple of students who has worked with him, and Mohammad Shahzeb would be there to answer any query. Professor Prakhar Dugal is also there online. Mohammad Shahzeb is there online to answer the query related to paper ID 100 and 103. So the students who are associated with this paper may please come on the stage. I may like to open the paper 100 first.
Good evening, dear judges, teachers, and all of my fellow members present here. Today, I, Ritik Jain, is present here to shed some light on the topic effect of subgrade modulus, thickness of slab, and type of loading on the performance of grade slab using finite element of software StatPro. What is grade slabs? Slab on grade or grade slabs are slabs that are directly set on the ground to support walls and on other structural features. This is sort slab is cast directly on the ground. Depending on the load, type and intensity, this type of slab may or may not have reinforcement. The decision to add reinforcement is influenced by the floor loads and local construction codes. In other circumstances, the slab is directly cast on the ground and columns and walls are erected directly from the slab in lightly loaded single-story buildings. Depending on the requirements, the slab at the column sides may be thickened. The thickness of grade slab is limited to 4 inches. In addition, before picking the concrete slab, a layer of gravel and bitumen is spread on the ground to prevent moisture from entering the slab. Now, we come on classification of grade slabs. Classification based on the exposure in open atmosphere, inside a building, shed. Classification based on resting medium, resting in virgin soil, resting on filled up soil. Classification based on soil medium beneath it. Sand, clay, rock. Classification based on uses. Industrial floor slabs of control, process buildings, floor slabs of warehouses, parking open, etc. Now, this is the composition of the grade slab. Like we come with the RCC slab, which is 200 mm, sub-base M10 concrete PCC, 100 mm subgrade boulder, plus soil, plus sand, 300 mm, and then there is a layer of compacted soil. These are the literature review which we have created by using all the following authors and their information by which we created this slide. You can see. Now, our objective to study the variation in structural properties of grade slabs by changing the subgrade modulus of soil, thickness of soil, grade of concrete, and type of loading by the use of finite element software StatPro to bring a comparative analysis between slabs of different combination on the ground of deflection, base pressure, percentage of reinforcement, bending, and shear. Now, I would like my friend Salman Ghani to take over. Thank you.
Thank you very much. Good evening, everyone. I am Salman Ghani, and I'll be talking about methodology. So to begin with, the design of the slab is 6 by 6. Just a second. Yeah. So we have taken two types of slab, that is partial UDL and point load, a UDL for uniform distributed load. The thickness of slab varies from 300 to 250 to 200 millimeter. To conduct a comparison examination of the outcomes produced by various lab combination, a table is created. Just could you move it? So at last, the 12 graphs were plotted to perform the comparative analysis effectively. 6 graphs of deflection against thickness and 6 graphs of base pressure versus thickness. As you can see on the slides, I'll be safe here. I'll just move to conclusion. So based on the result of the partial UDL and the point load test, it is possible to deduce that increasing the thickness of flat panel reduces both base pressure and deflection, regardless of the soil's subgradable modulus. And overall, these data imply that increasing the thickness of the slab panel, independent of the soil's subgrade modulus, is an efficient strategy to reduce base pressure and deflection. These findings can be used to guide future design and construction of comparable structures. Thank you very much. Have a great evening. Do you have any questions though?
So which sustainable development goal is this research related?
I'm sorry, what?
Which sustainable development goal is this research related? Which SDG goal? There are SDG goals, no? 17 SDGs goal? This research is associated with which goal? Out of 17.
Like it's basically on infrastructure, we can say. Infrastructure.
So this makes the infrastructure more sustainable.
Yes, exactly.
Exactly.
But why is it more sustainable?
So we are using UDL that is uniform. The load is uniformly distributed.
Excuse me, if you can repeat me the question. I think if I could answer the question.
Yeah, Mohammed Shazib, the question from the jury was that which sustainable goal does this paper help to fulfill? That's the question.
So if I talk about the full answer, it would go on for hours and hours, but I'll sum it up in a small words. What happens is that grade slabs are used where we need to store large quantities of commodities. For example, at dockyards and warehouses where you store food and grains, where in government facilities like buffer stocks and etc. So what happens is that if you don't cast a proper slab and you just lay out commodities on a ground, there is a very high chances that the food items you're storing or the paper rolls you're storing might get destroyed or that commodity might get damaged. That is why there is a very vast need to cast warehouse slabs, and in construction industry this has been a very gray area. So that is what motivated me to proceed with this topic. I hope that answers your question. In any if you have any other doubts, I'll be glad to answer them as well.
Thank you so much, Mohammed Shazib. That was a wonderful answer. And I appreciate that you have submitted 2 papers and your students out here are more than eager to be there on your behalf. And thankful to both of you. With this, we are winding up with the IEEE session, and on this track, we are able to present all the papers. I'm highly thankful to the jury of from IEEE who is here with us, Dr. Mona
Madam,
Jabir.
one paper is remaining from our side. Sujata, Madam, also present the paper.
Dr. Sujata, I called your name in the beginning. I remember that.
Actually, we have 2 papers, no?
We have 2 papers, madam.
One paper is
I have present one paper, another paper is remaining.
Okay, so one quick thing I can have that in the India office, the presentations are still on for tomorrow. I would request my team in the India office to have your paper presented over there. However, it will not make a difference. If that's okay to you.
But maybe it will take hardly 5 minutes if you'll say I'll just complete it.
Yes, only 5 minutes.
I think the jury will help at that time. It's I am already there. We have taken quite a time of there. Yeah, if you can wind up in 5 minutes, Dr. Sujata.
Okay, ma'am. Thank you.
Yes,
Thank
yes,
you.
5 minutes, 5 minutes.
Okay, ma'am.
Please go ahead.
Yes, ma'am. Is it visible?
I think it's coming up. Yeah, please
Yes,
go
yes.
ahead.
Okay. Okay. I am here to present our paper, that is impact of metaverse in near future. So these are the outlines of our paper. Introduction, metaverse infrastructure. So first, metaverse, this term is coined in 1992 by Neil Stephens in his book, that is Snow Crash. So the metaverse is basically the communication between authors. So authors are the programmable human interact with other software agents in 3D virtual space. Then this virtual world must undergo the 3 sequential stages: digital doppelganger, digital natives, and founder of physical virtual reality. Then comes to the metaverse accelerates the sustainable development goals. So it basically to promote the development of industries and entrepreneurship, and it also focused on the machinery of agriculture used and secure storage and distribution of food using blockchain. It also apply on healthcare domains such as e-health learning, e-health administration. Also, it can apply on e-learning. Also, it can apply on by using the IoT, AI, and big data and blockchain to manage and control energy consumption. This metaverse is also can applicable to tourism sector, fisheries, entrepreneurship, and cottage industry. This metaverse is also applied to the smart cities and towns. Also, you can explore the undersea exploration. Also, you can apply into the metro railway construction. So these are our sustainable development goals. So to have this metaverse, we use different technologies. So first is extended reality. So extended reality is your augmented reality, mixed reality, and virtual reality. Then with the help of user interaction and ubiquitous interface, metaverse can be good enough. That is like in COVID-19, we face that we need the contactless environments. So the metaverse can provide the contactless environment to us. Then IoT and robotics. So with the help of IoT, metaverse can see the new possibilities for the industrial area, individual demands, and social necessities. And artificial intelligence can helps the metaverse by taking the decision making. If the user cannot locate a specific item, so the chatbot may simply resolve the problem by referring the consumer. Then blockchain also helps the metaverse by providing a unchangeable digital. It is actually blockchain is a unchangeable digital ledger. So metaverse can take the help of blockchain, where metaverse can where the metaverse can do the transactions. So in that case, blockchain can helpful in that. Then computer vision. So in the when you're developing the opters, so computer vision will take the help of that. So to represent the facial recognition. Then trust and accountability. So whether when you're developing the metaverse, so we have to ensure the user have to opt a option, not a default option will be setting. Then last in the next, we'll see that there is 6 ecosystem factors which can affect by the metaverse and society. These are the privacy threat, user diversity, fairness, and user addiction, cyberbullying. And the research agendas we have discussed till now: extended reality, user interactivity, IoT and robotics, AI, blockchain and computer vision, and trust and accountability. So, and we conclude that we have seen different technologies to developing the metaverse, and we anticipate that it will persist as another massive entity parallelly to our physical reality. And with the help of new technology deployment, continued evolution, and the ecosystem improvements, the virtual world will look radically different in the next few years. Thank you.
That was very quick of you, and thank you so much, Dr. Sujata, for your time. Any questions All right, the jury don't have the questions, and I appreciate. I'm sure over there in India also it would be past night.
Yes, ma'am.
Yeah, thank you. 11 o'clock in the night. All right. Thank you once again to your team. And congratulations to all the presenters over here. And a huge round of applause for all of them, please.
Thank you.
The judgment is being prepared by them, and tomorrow during the valedictory that would be announced during the valedictory session, the link will be circulated to you. Meanwhile, we further go ahead and we owe our special thanks to the people from IEEE, especially Dr. Mona Jaber and Professor Nagma Sayyed, who are here since morning with us. And it was a tremendous cooperation from their end
because there were lots of paper and there were passionate researchers who wanted to explain their research well. And I'm highly indebted for your time to both of you. I hereby invite Dr. Meghna Sharma, the Director, Undergraduate Program, Amity University, and Professor Ajit Mittal on the stage to felicitate Dr. Mona Jabbar and Dr. Nagam Sayed. Please, on the stage.
Yes, yes, please.
I will
Yeah, you can also join. He was keeping on phone. You can invite बेटा बाहर से आने से बुला लो.
Thanks so much for being here. Did I already? Thank you so much. That was a very long day for you all. Oh, I feel the same for you. I'm sure you did not even have any of the lessons. That's actually really nice. You started very early in the morning. But I thought about both of them. Thank you very much. Thank you. Thank you. And here we wind up. I bid adieu. I bid good night to all the people and presenters over here. Thank you so much. That's it.